Alright, here's video 2 of adding and subtracting and multiplying radicals. So here we go. Alright, so adding and subtracting radicals. Let's start here. So I got to take a look at each radical term. So they're being separated by this subtraction sign. So I have to treat each one individually. And what I'm always doing is I'm trying to simplify the radical down first. And here's the end game. The end game is I want the stuff under the radicals to be the same in both expressions. So here's how this works. So 27. So square root of 27. I know I can break that down to 9 and 3. So square root of 9 times square root of 3. Square root of 9 is 3. So I got 3 times this 3 that was already out here, times the square root of 3. So that is 9 radical 3. Then I'm going to come over to this one. So so square root of 12 can be broken down to the square root of 4 times the square root of 3. Square root of 4 is 2, so it's 2 times this negative 2 times the square root of 3. So I got a negative 4 radical 3. Now, if I have the same radicands, then I can take the 9 and the 4 and I can subtract them from each other, leaving me 5 radical 3. Don't try to do 3 minus 3. That does not work. And you are done. You know you're done when the radical, the number under the radical sign cannot break down any further. So that's the premise. We're trying to make sure that the stuff under the radical is reduced as far as it can, and we're trying to get them to be the same stuff under the radical. So just as a heads up, this one worked out really pretty because I'm just setting a precedent, but it is not uncommon. In fact, it's more common than not that you're going to have a really long, god-awful answer. So not a big deal. Just you need to make sure it's mathematically sound. So let's jump into this one. So this one, I'm dealing with cube roots. So now you got to make sure you got a good command of your cube roots. So cube root of 54, I know is the cube root of 27 times the cube root of 2. Why do I know that? Because I'm a genius. And I worked them out earlier just to make sure I had my head screwed on straight. Minus 2 times the cube root of 2 plus 7 times the cube root of negative 16. Okay, now cube root of negative 16, I know it's cube root of negative 8 times the cube root of 2. Okay, so my hand's hurting here. So cube root of 27, let's start here. That can break down to 3. And there's already a 3 out here, remember, so I'm just going to bring it down right next to it. Cube root of 2, can't do a thing with it, so you just bring it down and it's happy-go-lucky. So you got 9 times the cube root of 2. Alright, this minus 2 cube root of 2, well, this ain't a thing you can do with that, so just bring it right on down. So then you got this plus 7. Right now the cube root of 8 is negative 2 times the cube root of 2. So 7 times that negative 2 gives me, oh, I should have put a plus sign there, negative 14 times the cube root of 2. So here's one of my trademarks. I have all 3 numbers under these 3 radical signs. They are all the same thing. This is good. This is what I like. So now I treat these like, they're like terms, I go left to right, what occurs first. So I have 9 minus 2 is 7. So I got 7 cube root of 2 minus 14 cube root of 2. 7 minus 14 is negative 7 cube root of 2. There's your answer. Alright, so let's jump down to this number 3 right here. This is where I think they start getting a little more interesting. So I have 7 times the fourth root. Oh yeah, this is gonna be interesting. Anytime you got fourth roots, fifth roots, sixth roots, I mean they can go on forever. They get kind of fun because they're stretching you thinking there. So 48. So remember, if you have to, list all your perfect fourths, or in cubes and squares. List them on the side of your paper somewhere. That's something you just have to do. So I happen to know that is the fourth root of 16 times the fourth root of 3. Over here I have 2 times the fourth root of 3. Well, that's pretty much done. Alright, but now look right here, they snuck in a cube root. Sneaky devils. That's okay. Let's go ahead and handle it. So that's 3 times the cube root of 8 times the cube root of 9. Okay, so cube root of 8. We'll go ahead and handle that since I'm over here. So that's 2 times that 3. Cube root of 9 is just cube root of 9. There's not a thing you can do with that. Okay, so that's going to be a 6 cube root of 9. Okay, it's positive, so it says plus. You got negative 2, fourth root of 3. All right, let's back up here. Fourth root of 16 is 2 times the fourth root of 3. So that is 14 times the fourth root of 3. Now these I have some like terms here, so these can actually be handled. I, however, cannot do anything more with this. I can't take this and try to put it into this. That doesn't work. So I'm going to have 12 fourth root of 3, because they are the same, right? Plus 6 cube root of 9. Guys, that is done. There is not a thing you can do with that. That's just the answer. Remember, I said earlier, there's going to be like some really wonky looking answers, and that's okay. That's not a big deal. So let's take a look at this one. So cube root, whew, thank God, back to that. Cube root of 40 is that can be broken down to the cube root of a negative 8 times the cube root of 5 times the cube root of a to the 7th. Plus, and I got this 2a squared, and then you get the cube root, boy, this is going to be tight right here as I'm running out of room. 135, that is 27 and 5. You'll have to pardon how tight it is here, but cube root of 27 times cube root of 5 times cube root of a to the 4th. That's what's written right there. So here we go. I'm gonna take care of this first. This is so tight. Cube root of 27 is 3. Cube root of a to the 5th is just I'm sorry. Cube root of 5, that is. It's just cube root of 5. Cube root of a to the 4th. By now you should have enough insight into this to know there's 4 A's, right? So 4 A's, 3 of them are going to go out with 1 of them left over. So that's 1A cube root A. If you need more information on that and why that works, go back and review some of the notes we took on the other video. So all of this right here, so remember the stuff on the outside, 2a squared times 3 times this a right here. That's going to be 6a cubed cube root 5a. Ugh. That's only half the problem. We ain't even done yet. That's okay though. That's what makes them fun. So this right here is 2 cube times the cube root of 5. Alright, so right here, 7 A's. I can pull 6. So it's two sets of 3. So that's a squared Then 1 left over, that's a. So that's 2a squared cube root of 5a. Oh, goodness. So I'm fortunate that stuff, the same radicals right here, stuff underneath the same. So I can add these. So I can say, I made a mistake. Right up here, that's negative cube root of -8. That should be a -2. However, no. I stand correct. We can't combine these because the 2a squared and the 6a cubed are not like terms. So this weird wonky looking thing, that is it. That is it in a nutshell. I'm gonna take a side note real quick. I'm gonna go back up here. I feel like I just need to hit on this again. So say you have cube root of x to the 9th. So some of the stuff I was doing down here, a lot of it I was doing in my head, and you may not be to that point yet. So let me explain what I'm doing here. What I'm doing is I'm saying, okay, I have, and I'm just going to really just draw it out for you. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's make that 10. Instead of making that 9, let's make that 10. So in my head, here's what I'm doing. The index being 3, that means I can circle a set of 3 here. And that right there is representing 1x. Another set of 3, that's another x. Another set of 3, that's another x. Now, you got that 1 remaining, right? And it's still stuck under the radical like this. So that's x cubed cube root of x. That's how I'm doing that. Now, going back to the property that I taught y'all on the other video, this is like saying power over root, right? So you're saying x to the 10 thirds. So 10 divided by 3 is saying x to the 3 1/3. Agreed? So I have a total of 3 x's that came out. And then I had 1/3 of it left over. 1/3. So that's another way you could look at that. And you may have to rewind this video a few times just to really let that where I can sink in, because the reason I do it so quick and smooth is because I've done it for a long time, but you need a little practice with that. But that's really what's happening. Okay, multiplying radicals. Here we go. So again, I always try to make sure these things are reduced. Simplified. Simplified. So I look at square root of 27, and I'm like, okay, so that's square root of 9 times square root of 3. Square root of 9 is 3. You have 3 radical 3 times the square root of 5. So you have 3 times the square root of 15, because I can take the 3 and the 5 and I can multiply them together, because it's not adding or subtracting anymore, this is multiplying. You always check to see if this can break down. If it can, break it down further, but in this case it doesn't, so you're done. Let's jump over to this one. Square root of 10, there's nothing. 5 and 2, 10 and 1, nothing breaks down. Let's look at this one. Square root of 18 will. That's the square root of 9 times the square root of 2. There's a -2 sitting outside of here. So you got -2 times 3 times square root of 2, which is saying -6 radical 2. Okay, now that is all being multiplied to that 3 radical 10. Now watch what's going to happen here. You're going to multiply these. You're going to get -18, the 2 numbers outside, times the square root of 20. Now, the square root of 20 can break down. That breaks down to the square root of 4 and the square root of 5. square root of 4. I'm sorry, I should bring that negative 18 down. So you got negative 18 times 2 times square root of 5, which is negative 36 radical 5. Whew, last one. All right, so here we go. So cube root of 9 doesn't break down. Cube root of 24. That'd be the cube root of a negative 8 times the cube root of 3. Yeah. Times 5. 2 cube root of 9. Okay. So cube root of 8 is 2. Negative 2. Lord, don't need to make that mistake again. So that gives me a negative 10 times cube root of 3 and 2 cube root of 9. Okay, so I got a negative 20 times cube root of 27. So cube root of 27, can I break this down? I can, because the cube root of 27 is a 3. So negative 20 times 3 is negative 60. So you're always, in your mind, you're always replaying this thought, can I break it down? Can I break it down? So I knew this one, I knew cube root of 9, even though we see a 3 and a 9, we automatically associate those like, oh yeah, there's something we can do. No, you remember you're saying what number multiplied by itself 3 times gives you 9, right? And there's nothing. So you're always in your mind working, thinking, okay, is there one? Can I break it further? Can I break it further? It's almost like you're paranoid. You want to be sure. So I saw this cube root of 27. I'm like, oh, because I know my perfect cubes. 9 times 3 is 27, right? So that is the conclusion of multiplying, adding, and subtracting. Pretty much every type of problem you're going to experience hinges around what I've been showing you. They may be a little bit trickier, they might have more to it, but the concepts are the same. So you're always looking, is there something to simplify? Can that radical break down any further, and can I add or subtract? The key to understanding these, and the key to being able to do them well, is knowing your perfect cubes, and knowing your perfect squares. Not a bad idea to know your perfect fourths, although those aren't quite as common. It's still handy, and it's as simple as taking your calculator, taking about 10 or 15 seconds, and on the top of your paper, I would go at least, like if you do your perfect cubes, I do 2 cubed. I go it up at least to about 10 cubed. I think that's pretty safe. And just do that with your perfect squares and your perfect fourths. And just have them listed there. Because if you got that right in front of you, you tend to remember it better and be able to apply it a little bit easier. So, I hope that helps. And remember, hit subscribe.